Oh boy, guys, I'm in a good mood. I'm catching the stride. Things are clicking off. I just feel good. It's one of those seasons in life where things are just clicking off and go well. I'm gonna turn y'all up. I'm gonna turn y'all up. It's things are going phenomenal. I got some amazing news to share with y'all sooner than later. Okay, just had to offload some of that excitement. Some of that tenacity, some of that emotional resilience, folks, and brilliance. So what are we learning today? Guys, I gotta be honest, I'm kind of bummed. We're about wrapped up on learning Solidity. We got like one or two more videos after this, and then that's the Solidity series. That's the fundamentals. I am developing a course about it, a little bit more granular stuff and how to deploy contracts on test networks and things like this. But let's talk about this voting contract. Let's learn some Solidity together. Let's do this. Okay, so voting contract. In this tutorial, this very tutorial, this one, not the next one, not the last one, this one, we're going to build a voting contract. We'll use the lessons learned here to understand how the governor's standard emerged. Sweet. This is going to be cool. Okay, so we're going to focus on creating a voting contract that will allow members to create new proposals. Sounds like a bunch of ERC tokens are getting engaged, folks. Okay, so this contract can contain many proposals which will be voted on by a group of members. Each proposal will keep track of its voting to decide when it's time to execute. Cool. So it's a group come together, a little democratic way to get things done in a protocol. Okay, so at execution time, these proposals will send call data to a smart contract. The call data could be anything. We could have a voting system that allows 100 members to decide when to upgrade a protocol. That's kind of cool. So 100 people can decide we want to upgrade today or tomorrow, next week, whatever. Okay, so the call data might target a function with the signature upgrade address and send over the new protocol implementation. That would be a very cool use for the voting contract. Okay, so fundamentally, we're building this democratic voting box, if you will. Think of it that way. Let's get our head out of the Web3 big buzzwords. Obviously that's like inherent with the industry, the culture, the technical words, but I always like dumb things down. Try to distill it. Try to think of it as the most palatable thing. So we're building an online voting box, right? Let's think of it that way. Okay, so proposal storage. In this stage, we're going to focus on the storage of new proposals. A proposal should take in some call data and a target. When the proposal passes the voting stage, the contract will send the call data to the target. Okay, so to begin with, the yes count and no count should be 0 until we record some votes. Cool. Okay, so create a public array of type proposal and call it proposals. So we have a struct, which is our type basically for a proposal, which has the address, the data, whether it's a yes count or a no count. Okay, so it looks like we need to do some. So create a public array. Let's say UNs, or what would this technically be? Would it be a proposal deal? Proposal. Guys, I got to sneeze. Hold on. I got to sneeze real quick. It's got to be public. Oh, golly. Okay. So I think something like this. Let's see. Do we need to define it, type this or something? Okay, so create an external function called new proposal. Let's see. So function new proposal. Proposal. Okay, and it takes in 2 arguments. Did we spell that right? We did. Okay, great. So an address argument is going to be the first one. So we'll go ahead and pop that in here actually, and we'll underscore it just to declare that this one is the address argument being passed in. And then we need hold on. So target address of the proposal will send some call data to this address. Interesting. Okay, so keyword here is call data. Call data, that's a key word, folks. Okay, so a bytes argument, which will take in which will be the call data to eventually send the smart contract when the proposal is executed. Okay, so I'm honestly not too confident on this bit right here, the bytes argument. So a bytes argument, which will be the call data. So I'll just say this maybe, bytes data. Do we need to prepend it with call data is the question. Probably not. Okay, so I'll say external. And what are we going to return here, right? So the new proposal, what it I think is going to do is just update the count to the proposals here, right? So in the new proposal function, create a new proposal with the arguments passed in and the yes, no votes started at. at 0. So we'll say proposal, and I'll go ahead and say new proposal, or name it proposal like this. And I believe we actually need to do one of these where we pass in all the arguments here. So this is our type for the variable, and this is our struct, which we're going to define all of these things right here. So we actually need to pass in all of these things. So we need the address, we need the bytes, and then we need to initialize it with a 0 count for yes. And so maybe I'll make it a little bit more clear. So these are our actual things coming in. So I think I can go like this, right? I think that'll work in Solidity as well. So I can go like this, pass in the data here. So I'm assigning that to this parameter, if you will. And then the yes count will start with 0, and the no count will start with 0 as well. But I don't think we have to do the keys. We can actually just pass in just the values like this, and they should know to be part of each thing, I believe. So we're gonna see how many things we broke here, but we're also going to see what we've done correctly. So add the new proposal to the proposals array. Got it. Okay, so proposals, and we'll push the proposal. Okay, boom. Let's see. Bytes data. Oh, memory or call data. So we do need to prepend it with some call data here. I believe is going to be storage. No? Okay, let's see what we broke here. But I believe we're on the right track overall. I believe such. So let's see, proposals. Ooh, proposals.push. They flexed on us. Look at this. They just went ahead and made that all one step. They just put that into here. Boom, like that. Okay, so we have address, which is the target. So this is fine. If it's a different name, it should be fine. They're just calling it the target. And then we have to do call data, which we've done. Okay, so I actually don't know why this didn't fully come through, to be honest with y'all. Looking at it, it still roughly should work. But let's go ahead and streamline a few things. So I'll go ahead and pop this in like this. Let's see if that was it. Boom, bada, bang. There we go. There we go, folks. Okay. Yeah, let's move on. I was going to sit here and say, let's figure out why this didn't work, but tomato works. Okay. So let's cast a vote. Let's cast a vote now. So just redefining this again, we have our proposals here in that are being pushed into an array. This is our memory of proposals, and we have a function that can now add these new proposals in there. Like I said, like sometimes software engineering, and I get a bad rap for this a lot because I'm always like having this kind of like loosey-goosey mentality, but it actually helps me learn tremendously fast. And I'm not saying it to be like rude or hopefully not too conceited or arrogant, but I think sometimes when we get in front of the terms of like decentralized, autonomous, blockchain, crypto protocols, Kakash SHA-3 hashing algorithms, all these things, it's like, don't call it a hashing algorithm, just call it a little letter scrambler, right? Now all of a sudden it sounds dumb. It's like watered down. It's like a letter scrambler. Yes, that's literally all a hashing algorithm is. But people will look at me if I'm like, oh, you built a letter scrambler. They're like, you just sound dumb, But it's like, that's actually how you want to learn is. So when I talk about this as the voting box, like it's a digital voting box. Like it takes away all the sheen on it. Although we're building this blockchain voting proposal, take all that out of it. So obviously that's good for marketing, but for learning and educational purposes, I think it gets in the way. I really do. And I think add it back in when you're, a hashing algorithm. Oh, we're learning the Kakash 256 from the SHA-3 family hashing algorithm. Boom, bada, bang. I'm here for it. But when you're first learning it, try to water it down. No, it's a letter scrambler. Okay. So let's learn more. I don't know. I don't want to propose that I know everything. I don't want to make a function of a new proposal that Pags knows everything. There's a no count on that. I don't know everything. But okay, so let's build here. Okay, create an external function, cast vote, which takes a uint. Let's see. So function boom bada bang, cast vote, which takes in a uint. Proposal ID. There it is. Okay, I was like, polls. Thought it was an LD there. Made no sense in my brain, but okay. So anyway, here we are. So, and a Boolean, which indicates whether the vote supports the proposal, true as yes or false as in no. Okay, so the Boolean, I will just say supports proposal. We'll just keep it that simple. And this is supposed to be an external function. And let's see. So for each vote cast, update the yes count and the no counts reference to the proposal accordingly. So I wonder if we have to do some of the looping stuff again, where what did we do before we code? Let's chat. Let's chat. You and I, it's a one-sided conversation at this moment, but let me ideate out loud. Okay, so we don't have a find function, right? But what we can do is loop through all of the proposals and match the proposal with this proposal ID. And then if they support the proposal, we're going to index up the yes count. And if the proposal's support comes in false, we'll down count. That's the rough plan for now. Let's see what we can do. Let's see what we could do. So I'll say I less than proposal. So we're going to begin that loop here. Proposals.length, and then we'll index through. So I++, and let's do this. So the proposal we are proposing here is going to be the one with this ID. So that should be one proposal. And what we want to do, let's think. So I actually want to define this type for now. So I'll steal the proposal type, and I'll say proposal, and that's one proposal. And then let's make some if statements. Let's make it as easy as this, right? So if the proposal, if supports proposal, here we go. Now we want to say proposal dot yes count index up. Else we could just do this, because else if doesn't support the proposal, it defaults to the negative side. So let's go ahead and try for this, right? Let's see if this works. And then I believe we may just need to return the proposal. Okay, let's try that, all right? Storage data always bites us in the butt. Okay, let's see. Call data, no. It doesn't like all that. So let's do this then. Let's take one proposal. This will be our one proposal, and then we'll do this for the other one. Maybe that'll work. And then we'll return the proposal. We actually may not even need to return it. But let's muck around, let's see. Sweet. I don't think we needed to return it, guys. Oh, I was about to flex so hard. Say first take, Drake, and we weren't even close to the first take, but and it didn't go through. But okay, so what was the error? oh, we can't just decrement. Oh my gosh, silly me. We can't just decrement it. We have to do this. Silly me. Okay, sweet. So the vote is cast. Awesome. This is cool, guys. I love this. I love it. Okay, so multiple votes. We need to handle the case where an address votes two times. Not one, but two. This is one of them shiesty votes. One of them shiesty vote boxes. You know what I mean? Okay, so speaking of dumbing down terms, we call that corruption. We call that maybe United States reason. I don't know. If I go missing, my bad, guys. Your teacher's gone. He knew too much. So I'll go back to my proposal. I don't know very much, folks. Okay. So one potential way to handle this is to prevent voters from voting twice. So what if they want to change their vote, though? Let's allow the functionality of the voter to change their vote. It will require that we account for the vote change in the vote counts. This means that if the address previously voted yes and then switched to no, we'll need to decrement the yes count and increment the no count, and vice versa. Okay, so let's modify the cast vote function to allow voters to change their vote on particular proposals. So we're going to need the address so we can do the message.sender deal. The implementation of this is up to you. Great. Let Jack Sparrow steer the ship, folks. Come on now. All right, so you'll need to figure this out in a new way to track which addresses have already voted on the proposal. Ooh, yeah, that's a mouthful, folks. That's a mouthful. You know what I mean? That's a mouthful. Okay, so let's, before we hop in the code, let me buy some thinking time with you. You know what I mean? Let's get a little thinking time. So this is just a little you and me time. And I'm just honestly buying more time to think about this while I talk. Okay, so what we could do is we do need to pull in the address somehow. So whether we take it in from the cast vote deal or the message sender, I think will work. But let's think. Okay, so we take in the message sender. We need to add that to the proposal. Whoa, did I just get balloons? Did you guys see that? Did you see that? That was so cool. That was so freaking sweet. I was wondering what was going on, and then balloons just started. I don't know if it'll come up in the recording, but that was cool. I think it's because I said the proposal word so many times. It probably auto thought I was doing some proposal deal. But anyway, okay, so hopefully that animation comes through, by the way. Otherwise, that was just a complete wild thing for y'all to experience. But okay, so anyway, let's think about it. So the message sender should always be the one casting the vote, right? So if I want to change the vote that I vote, I'm going to be the one casting the vote, correct? That seems appropriate. So the msg.sender should be the voter, the address that voted. Now we need to, let's see. So they have an address here. Is this the target? What was this target again? Was this the That's not the person who voted, right? So we almost need a mapping of people who voted, I feel like. Some sort of way to track who voted, to be honest. We got to do that. We got to do that. So I'm thinking of nesting a struct within a struct. I don't know if that's going to be a smart idea or not. So, but let's just go for it. Let's just go for it. You know what I mean? So we can either do a struct and a struct or some sort of mapping. So maybe we start with the mapping, right? So we want an address voted to maybe like a Boolean, like has voted. Yeah, that would work, right? Yeah. Totally that would work. Okay, so here we have our voters. That's what I'll call them. Maybe we'll make them public. That's fine. We'll make them public. Voters, not voters, folks. And what we could do is say, is the message sender one of our voters? If they are one of the voters, we need to do the decremental dealio, and then if they aren't, don't do the decremental dealio, right? I think they would work. But my brain is telling me that's gonna work. My brain is like Ryan, it's bulletproof, it's a armor-proof plan. Do it. So let's do it. We're gonna need to do a similar thing here. And what I'm gonna do, and then we'll also need to build some guard clause as well. So if they've gone ahead and voted. Oh, but then we need to push them in if they voted. So this might be a little more tangy than we thought, but okay, let's try to fix it. Or let's try to figure it out. So I'm gonna loop through the voters, and let's just start there. So we're looping through the voters, and the voter is gonna be the voters msg.sender. So this represents one voter. I would be this voter if I casted this vote. This would be me. And what I need to do is a few things. I feel like I need to add a voter in there. If they're not in there, we have to push them into the voters array. So maybe we could do that here. So voters push, and we need to map an address to a Boolean value. Okay, so how do we do this? How do we do the mapping deal? How do we map a deal here? Do we do msg.sender and then pass in true as in they voted? Would this suffice for our mapping? Okay, so we'll leave that up in the air for right now. But so the voters msg.sender. We need to know what they voted. We need to know what they're voting. Maybe we just add it to this. Okay, you know what? Yeah, let's just add it to this. You know what? I might have overthought it a bit here. So let's say addresses. This will be an address array of voters. Boom, here we go. Okay, so let's do this. I think this will work a lot better. Okay, so we need to say proposals. We're gonna push in the address after someone votes. Okay, this makes a little more sense in my brain. So we do need to do the object of, let's see, new proposal. I will maybe put in an empty string here to initialize the proposal. Maybe there's no voters initially. Seems appropriate, right? Seems appropriate for me. Will that actually work though? And then we need to send in the object here of the original proposal, right? The original proposal plus the message sender. Okay, you see how my brain's hurting now, folks? Because now we have to send in the MSG sender as well, right? With this thing, but it needs to go into an array. So it actually needs to be some sort of method, right? I don't know if this works in Solidity or not. So there's going to be some issues here syntax-wise, but this is how my brain is thinking of it. So we're going to initialize the proposal with no voters. And then after a voter votes, we're now going to push them into this. So the original proposal, they'll be pushed in with. I don't think we've done this correctly, but this is the idea. And then on top of that, we'll push in this array for that final spot there, which I think I'll need to change. But what we can do now is some sort of voter deal. So if the voters already voted, right? So if proposals, let's see, proposals dot proposal ID, and I think we do one more dot voters, right? So this could actually be like the sub loop, the J loop within this, which might be a little bit expensive. There's got to be a better way to do this. Oh, right here, boom, duh. We don't have to loop right through. We just say msg.sender, just like this, right? If the proposal ID dot voters is the message sender here, now we could do some stuff. Now we could do some stuff, folks. Now we could do, I believe. So we could say basically the same thing here, I believe, right? And we're just going to swap this out. Actually, I don't even think we need to because it's still the same logic. Yeah, if we do this, we just need to swap out. Actually, yeah, I think that's it. And then we just need to return it before it goes to the next bit of the loop, right? Because we don't want it to go to this part now because it's already answered the dealio here. So I think it's the right idea. It's the right logic. I don't know if we got it syntactically correct. I don't think we're there with it, but I do think logically we do have that bit going for us. So if there is a proposal, we could actually just default them to this if they're not. Yeah. Okay. That's a bit of logic there. Yeah, that's a bit of logic there. And doesn't look very proper, but I do think it is the right thing. So I'm gonna actually take the ChatGPT real quick just to syntactically clean it up, and let's see if the logic was correct, right? Let's see if the logic was correct. Okay, so let me see. Can you clean this up? I forgot to clean up the syntax and whatnot. Boom. But let me run it over again. So we just added the voters bits here. We're pushing in an empty array of no voters because obviously they're not there. Oh, okay. So let's see. ChatGPT's throwing some logic, but I do believe that this was right mentality, wrong syntax. Right mentality, wrong syntax. Okay, so let's see what we got. See what we got here. Hold on, folks. Copy it and paste it. Boom. Okay, so this is what they've gone with, is mapping it for the array, which makes sense. This is, again, what I've done, but that's the correct way to do it. The Boolean exist, I'm not sure on what that deal is there. So let's see. So we have proposal push. Ooh, don't like this. I don't know what they're doing here. So new prop. Targets. Oh, I see. So it's just assigning things after. Oh, that's kind of cool. It's not actually including these three, right? So this is what it's doing. It's first initializing these three things. It's not actually including these things here. Initially, I wonder if it'll still pass the test or not. And let's see what it's done here. So require that the proposal ID actually does exist. Love it. That's a good check. Okay, so proposal storage, it's initializing the proposal at this point, saying this is one proposal, is the proposals with this ID. Okay, love it. Proposal, ooh, but we actually want to allow them to vote. So this is not going to work here. But this is going to be a bit of our logic here. So let's steal that. Let's leapfrog off of this. So this means that a proposal has voted, and we need to reintegrate that crazy bit of logic, I think, or some variation of it. So here's the logic that's going to work for if someone supports the proposal or not. So that looks like that should work. And then the proposal voters message equals true. Okay, so let's see. Let's steal this bit of logic actually, and we'll need to do two things, right? We'll need to return it before it breaks out of the loop. So the entire function stops there. And then we actually need to do this down here. The yes count, I forgot this. We actually need to get that decremented, and the no count is to get decremented if they voted yes the first go around. So I think that'll work. Let's send it. Let's see. We're missing a dealio right here. Let's see. Fingers crossed. Come on. Dang it did not work. Ooh, because they didn't initialize the deal right here. Okay, so let's go ahead and initialize this. How can we do this? We did it originally. We passed in this guy. We'll need to pass in the data one more time. We'll need to initialize with 0. We'll need to initialize with 0, and then we need finally we could get rid of this. We can get rid of this. We can get rid of this. How does he add the voters bit? Proposal.voters message sender equals true. At which point does he add to the voters or ChatGPT? When is it here? voters, this just looks like I don't really see, or maybe I don't understand how it's going on. So I'll just put an empty array there for now. Let's see. And then exist, we'll put a true. We'll start with that. Ooh, the empty array. That did not work. Okay, so that is where voters deal is kind of mucking up for me. So I'll try to okay. Let's just cut the guesswork. Let's see what's going on, right? Okay, so function new proposal. Is this what we have or is this what they have? Oh, this is what they have. So ChatGPT was right on the deal for doing all this stuff. Okay, so what about all this stuff? So boom, vote states, got it, nice. So we don't need the exist deal. We do have some bit of logic list that's working, right? So if proposal, vote states, message sender. What did we do? What did we do? What did we do? Let's get rid of this Boolean deal. It doesn't look like we need all that. And I'm gonna reinstantiate this bit right here. That was proper. That was proper. Guys, this is the stuff I live for. It's just wrestling with like dumb syntax and like really trying to understand the logic and then putting the brain to the syntax, because then it's like, okay, now I feel I'm learning. Great, obviously get an assist, definitely aid on both sides, reading the stuff here, but then deeply understanding it is super important. So let's see, proposal target looks like data. Oh, exist. I can get rid of that one. We deleted that prop. It no longer exists up here. Okay, so we're boom, we're initializing it. They do storage proposal.push. Pretty impressive, ChatGPT. So require proposal ID. We'll get rid of that require statement. Not a problem. Even though it's probably good practice, but just we'll get it out of here for now. To me, I thought it would work, from this point forward, pretty much, right? And you vote perfect, yeah. Let's see, vote states dot yes. So how does it do the vote states deal? Vote states dot yes. Oh, it added the vote states. Completely missed that enum there. Got it. So we needed that. That's a key part to the whole puzzle. That was a key part to the whole puzzle. Okay. So let's boom vote states, and we can say voters or vote states, one of the two. And here we go. So for the voters, if we have them here, how did they do that? If supports, will that work? No, that won't work. Proposal.voters, if, I see. Yes, right? Voters.yes. Isn't that what we're doing? We're appending the address to the vote states, which is one of these. So isn't this an address? This is an address, right? We actually don't need all this. Give it the old-fashioned one here. Isn't this what they did though? Isn't this roughly? Okay, so let's review the footage, review the game footy. Let's see. Okay, so we have the vote states again. Voters, boom, they called it vote states, but we called it voters. Still appended to the right type. That should work. No problemo there. Okay. So storage, boom. Wait, new proposal. Oh, yeah, there it is. Okay, boom. So then cast vote. We're there. Clear out previous vote. If proposal. Oh, that's all they're doing. I see. And they're letting it still go to the normal loop down here. I see. That's all they're doing is just, I see. I was thinking of stopping it from there, but they're actually saying, no, let it go all the way through the function to the vote bit. Okay, so if vote states dot yes, I see. They're actually using the type capital vote states up here now. So, okay, well, let's keep mucking around with it until it registers in my brain fully. So we'll say no count, and we actually just need to decrement the other one, right? And let's see, vote states. Boom. Is this it? Yeah. Oh, it's dang it. Okay, so A equals B equals A. So if vote states, boom. What did we miss, folks? What did we miss? We got the cheat sheet. We're still whiffing. Oh, I just had them inversed. Okay, so this is the yes count. If vote state is the yes count, you clear out the oh, I see. I'm doing the opposite logically. Okay, so if the vote state was yes, we actually need to permit the yes count to counteract the vote coming in. That doesn't make sense to me, to be honest. To be honest, actually, that doesn't make sense, because if I'm voting yes, oh, I guess it does make sense. Oh, that does actually. Okay, that actually does make sense. Because if I'm voting yes, it means my previous vote, if it was yes, take away yes. Likewise, if my vote is no, my previous vote, make sure it was removed, and then go ahead and add the new vote here. Got it. Okay, that actually does make sense. You gotta love software. You gotta okay, I'm still off somewhere, but that does make sense. Okay, let's figure out where I broke the code here. Let's see. And then I'll wrap it up. We'll have another episode here because this one was incredibly fun, but two, we need more time. We need some more time to download this information. It's proper information. Okay, so proposal storage, boom, boom. Guys, I know I could totally cheat and just like copy it, paste it. Believe me, I do that stuff all the time, but like for learning, I don't like to do it. I like to see where I'm missing something, right? That's what I like to do is see, okay, I didn't understand this. Why? If proposal vote states, ooh, there we go, voters, vote states. No, but I'm actually declaring voters. Yeah. So that should still work. That should still work. Vote states. Yeah, that's the thing we declared up top. Vote states, yes count, yes count. If supports proposal dot yes count up, proposal dot no count up. Okay, so that all looks good. Is it somewhere else? Vote, storage, proposals, push. Proposals. Address bytes, uint, mapping, address, vote states. Yeah, I'm not sure, folks. I am not sure, to be honest. Okay, all right. You got me. New prop. Let's see. No, that should all still work. Should still all work the same. I was gonna say, watch it work now. What the heck? So I'm gonna change that back. Actually, actually I won't. Let's steal there. So let's see where I broke the code. Oh, right here. Boom. And we're keeping track as well of what they voted. This was a key bit. Clearly, I missed. Okay, there it is. There it is, folks. Oh, there it is. So proposal.voters, boom, boom, boom. If they support, vote state yes and vote state no. That's what I needed. Proposal.voters. And we don't have supports, or we don't have underscore supports. We have supports proposal here. Let's see if it works. Now let's unpack the logic. Boom. Or not, but let's not. Let's just not. Okay. So proposal.voters. So this is the voters sitting in, and if they do support it, we're just tacking on that the vote state was yes, or that the vote state was no for this contract. But where does this get stored? Does this get stored inside the actual proposal? Like, do we need to push this in, or this automatically gets stored into the proposal? It must. This must automatically get mapped in. So if my address is OX123, this must automatically get stashed in there. Oops, did not mean to open up that tab, but this must automatically get stashed into memory like such. If I voted no, more of that, but okay, that makes sense if that's what's going on. So then a bunch of them would you guys would have another address, but maybe this person voted yes, maybe this person voted maybe. That was an option. Absent was an option, I believe. Okay, so that would make sense. That's what gets stored in memory, and then every time we vote, it actually gets adjusted. So if I switch my vote, boom, we actually do this, and the vote state deal. So voters would equal some bits of logic and memory. That seems appropriate. Okay. Awesome, guys. I'm gonna wrap it up here, guys. Thank you so much. That was a lot of fun. Very, 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 very informative. Definitely learned a lot, and we got to the nitty gritty. I love it. I love getting to the nitty gritty of stuff. It's so fun. I'm gonna catch you guys on the next one. I will see you soon. Cheers.